Hello and welcome to our SiLift screencast. Today I want to present the SiLift tooling environment in the so-called Workspace update context. So I therefore have installed the SiLift tools in the Eclipse Kepler modeling environment, as you can see here. So let us now first take a look at the concept behind the Workspace update. This is our first part of this screencast. So we have a remote repository and a local workspace. And now we have two developers who checked out the basic model. Both developers have edited or modified their model, whereas the developer in the repository has committed his changes. So now we want to commit our changes also in this repository. You can see here. We therefore create a patch between the model V and the model V1 and want to apply this patch onto our model V2. So we can commit our changes afterwards and have a merged version. This is what I want to show you in the next steps. So let us first take a look at the running example before we want to interactively merge the two versions. So let's now take a closer look. Our running example is based on a ticket management system, which you can see on the upper left, which is our base model. It consists of a ticket, an office, an online store, a customer, and an event, which has two subclasses, concert and exhibition. Now both developers have changed the space model, and the changes are depicted in different colors. For example, the first developer has created a person with the attribute name. Additionally, he has changed the method name getInfo to getTinfo. Finally, he has deleted the artist attribute in exhibition and has introduced a new subclass soccer match to event. Now, the other developer has also made some changes. First, he has introduced the attribute name into the customer, and secondly, he has also changed the name of the operation getInfo to getTicketInfo. And finally, he has pulled up the artist attribute from concert and exhibition into the superclass event. So both developers have made different changes. For example, they have both renamed the operation getInfo, but they have chosen different names. They also have added redundant information. For example, the first developer has created a new class with the attribute name and the second has only introduced a new attribute. And finally, they both have changed the hierarchy of an event. The first developer introduced a new subclass, whereas the other developer has pulled up the artist attribute from the subclasses. As you can see, there have been different inconsistent changes made by each developer. So, for example, the artist attribute shall not be introduced in the soccer match subclass, which would occur if we would implement a naive merge. So let us now take a closer look at how we want to resolve this conflict. To achieve this goal, I first select the three models I want to merge with our SiLift tooling environment. I select three models, press the right click, select SiLift and the three-way merge. So first I have to choose which model is in which role. For example, we have a base model, a my model and a their model. So in our example, the model VB is the base model, the model V2 is the my model and the model V1 is their model. I press finish. And as you can see, the SiLift perspective has opened now. It consists of a diagram editor and a property view below. Left from the property view there is the execution report, which depicts executions and their failure or status. And above we have this operation explorer, which can be seen as a to-do list. Here are all operations listed which shall be applied onto our model. So left from this operations, there's a little symbol depicting the status. For example, all operations here are either modified or conflicting. So I cannot execute them onto my model without an user intervention. So I could try to execute all operations which are not conflicting on this button. I press it, and as you can see, nothing happens in the execution report. This is because all operations are either conflicting or modified. So let us now take a closer look at the operations themselves. So the delete attribute wants to delete the attribute artist in the class exhibition. As you can see, operation reports a missing object. This is because I already pulled up the artist attribute beforehand. So I could now right click on the operation and could choose what I want to do with it. So I press it and I have the option to apply it or ignore it, as you can see here. But let us first take a closer look at the other operations. So I choose the create superclass, which creates a person as superclass of customer, which you can see below. So this is the operation I want to achieve, so I press right click and apply operation. As you can see, the person has been created as a superclass of customer. It is also being marked as applied successfully in the Operation Explorer and also the execution report below. So I can now apply the create attribute. As you can see, it is now applicable. I want to create the name attribute in person. So I press right click and apply operation. So as you can see, we now got a warning that after the operation create attribute, there's some validation error. And I can either ignore this warning or revert the applied operation. But let us take a closer look at the validation error. I have a name in customer and a name in person. So I have to choose what to want to do. I revert this operation. And now the name is gone again. So I could now manually select the name in customer, delete it, save the model, and apply the operation again. As you can see, there is no warning and the name attribute could be created successfully. So we have this three operation applied. We could now choose to filter the successfully executed operations. So we now only see the operations we either have applied already or ignored. So let's take a closer look at the next operation, the rename operation, where the getTicketInfo operation shall be renamed to getTinfo. As we already renamed it, we don't want to override this rename change from the other developer, so we choose to ignore this operation. So now there are only two operations left, the delete attribute and the create subclass. So the create subclass wants to create a subclass of event called soccer match. We want to apply this operation. I press again apply operation, and as you can see, the soccer match has been created as subclass. As I pulled up the artist attribute beforehand, the soccer match now owns the artist attribute itself. But before we resolve this conflict, let us take a closer look at the last remaining operation, the delete attribute, which shall delete an artist in the exhibition. As I already pulled up the artist attribute, there's no need to delete the artist attribute in exhibition, it is already missing. So I could now choose to ignore this operation, as I already implied it by my pull up attribute. So I choose to ignore this operation. And finally, I have to move the artist into the concert, as now soccer match shall not have an attribute called artist. That's it. The last part, I want to show you the final results of our conflict resolution and what decisions I have made in this process. So the final result of our model is depicted in this diagram. We have made changes to the person and customer, to the ticket and to the event hierarchy. which means the soccer match and the artist attribute. So now let us take a closer look at our to-do list, so-called in the Operation Explorer. I unfilter the operations, and as you can see, I have 5 operations. So the delete attribute and the rename operation have been ignored, here and here. And the create superclass person with the create attribute name in person have been applied, and the create subclass of soccer match has also been applied. So I now have merged all the changes and want to save the model. And this is it. This is the whole screencast tutorial where I merged all changes.